Hi, in this short video tutorial we will be seeing MAJAN, which is an extension of AJAN to support realization and evaluation of multi-agent coordination into groups. MAJAN is provided in this GitHub repository, and this GitHub repository is already pulled and available in the desktop. More detailed information about functionalities of MAJAN can be found in MAJAN guideline document. Briefly, MAJAN provides template coordination behavior trees to execute request coordination protocol, coalition structure generation coordination protocol, and clustering coordination protocols. CSGP and clustering coordination protocols coordinate agents into groups. Additionally, in order to, once these behavior trees are being modified depending on the use case at hand, the agents need to be created, and then their local agent repository need to be populated, and finally the coordination need to be started. And for all of these reasons, MAJAN provides Postman collections. And finally, in the AJAN, MAJAN is integrated into AJAN editor, and here we have a monitoring functionality where coordinating agents log their activities, and we have an evaluation panel where we can evaluate the result of multi-agent coordination. So now let's start first with creating agents. To do so, we have MAJAN provides Postman collection, so we need to import it, and then we have 10 requests. By clicking on the run collection, we need to select the agents we want to create. So let's create 5 agents, and then we need to select the configuration file. For this is also provided in the same folder, and this configuration file contains the IP and port of the AJAN execution service. If you click on the run, it starts running those, creating those agents. Moreover, the second step is to populate the local agent repository, and local agent repository stores the information, contact information about other agents, so that they can they know how to contact other agents during multi-agent coordination. For that, MAJAN provides populate a layer folder and this collection, so we import it, and if we check it, we have requests. So we need to run MAJAN, this 10 MAJAN agents, because it contains the information of the about 10 agents, and their names are MAJAN agents. So we that's because we created the agents with the MAJAN agent name. In order to run this, we need to run collection, select the request we want, and then we need to select the configuration file. This configuration file is also provided in the same folder, so we just click it, and we can see that it has been created and populated. The next step is to start coordination, but since we have this monitoring functionality where coordinating activities can be logged, we need to activate this panel. To do so, we need to start we need to use this node MAJAN logging service GS. We need to run this command, which starts this server, and then by just click on the connect, MAJAN will be able to read these logs. And next step is to start the coordination. For that, MAJAN provides a Postman collection to start coordination. This collection stores requests for request protocol, CSGP, and clustering. Since we created 5 agents, we will be selecting this one, and in the body of this request, there should be a use case name, ID of participants, name of agent IDs, in other words, identification necessary, a timeout, which we should make sure that it is not an old time, a quorum, and the minimum size of the groups we want to have, and we send this to MAJAN agent 1 to the capability of send CSGP coordination request. Once we send it, agents inform each others, and we should be able to see the logs there. So we send them, and logs are being printed by being sent by AJAN agents, and MAJAN prints them. We have the time, ID of the agent who's sending this, a use case title, a solver, which will be written when solving the CSGP, and an activity which is can be flexible, customized, and specified by the with SparkQL queries. Also in the activity field, we can view the status of this multi-agent coordination process by checking this MAC status, which is currently running. And we have the status for the activity. So they are they're coordinating, and we can see here that CSGP solved, and we can see the status is completed. Status is completed, and at the end this is the result. So we can display this CSGP in the MAC solution section. To do so, we just need to provide agent knowledge repository name. So in this case, we can just provide the MAJAN agent 1, and so by clicking the refresh, we can see this problem instance which we just executed and its solutions. So on the other hand, we have central solution where we are able to execute central running grouping algorithms. To do so, firstly we need to upload a configuration file. These configuration files and these algorithms are provided in grouping algorithms folder. Since we executed the CSGP and it's being solved with BOSS, we need to upload this BOSS config JSON file, and if we click on the tooltip, we can view more information about this. For example, name of the algorithm, and path for the jar file, such that MAJAN can run it, and input structure, descriptions, etc. Second thing is that we need to upload an input to be passed to this algorithm. To do so, MAJAN provides these inputs in the same folder. Since we created 5 agents, we can specify this input. We just copy paste it here, and we need to give a name. 5. So since we have the algorithm and the input, it's just we just click the run to execute this algorithm, and we can see the results to be displayed. The next thing is the comparison. So we have selected the first and first, so we can see that the selections on the compare solution section, additionally their runtime, which is also available here. And finally, we can compute the NMI score, which basically describes how similar the selected solutions are. To do so, we need to specify a mapping between the name of MAC solution agents and the central solution, such that MAJAN knows which agent corresponds to which agent in the MAC and central. To do so, we need to specify name of the MAC solution agent and also the central solution. So since we created 5 agents, we specify 5 agents in the mapping file, and the NMI score is 1, which means the selected solutions are exactly the same. If we select a different solution, we can see that it is being reduced because the grouping, the groups are different. So that's all of the functionalities of MAJAN, that how we can execute.